Guru, made for you.
This is the lesson on linear programming. Linear programming is what businesses use to decide how much profit they can make, the maximum amount of money they can make. So let's find out how to do that. So our problem says Sarah and Josh are selling science workbooks and magazines. It takes them 1/2 hour to print a workbook and 3/4 hour to bind it. It also takes 1/4 hour to print a magazine and 1/2 hour to bind it. If each workbook sells for $2 and each magazine for $2.50, and they can't spend more than 3 hours printing and 5 hours binding a week, what is the maximum profit they can make a week? So we have a chart here to organize our data. So in the first column, we're going to put what we have. So those are workbooks and magazines. The second column, we're going to say how much we have. So the number. And we don't know how much we have, so let's assign variables, x and y. In the next column, we're going to see how long it takes to print one. So it takes 1/2 hour to print a workbook and 1/4 hour to print a magazine. And the next column will be about binding. And it takes 3/4 hour to bind a workbook and 1/2 hour to bind a magazine. And the last column will be profit. So how much money we're going to make. So workbooks sell for $2 each. So you make $2 profit off one workbook. And magazines sell for $2.50 each. So magazines give you $2.50 profit. And these last two boxes here are our total resources available. So I'm going to label total available. And for printing, it says we can't spend more than 3 hours. So 3 hours is our maximum. And 5 hours binding, so 5 hours is our maximum. So now that we have that, let's make our inequalities. So we are going to have a lot of inequalities. We're going to have 4 inequalities. So the first one is going to be about the printing. So we can't spend more than 3 hours a week printing. So that means all of our printing needs to be less than or equal to 3 hours. So we know how much time one workbook takes and how much time one magazine takes. So if we multiply the time it takes to print one workbook times the number of workbooks we have, we'll get the total time it takes to print X number of workbooks. And if we add that to how long it takes to print Y number of magazines, we'll need to put it less than or equal to 3 hours. So basically, we would do 1/2 x plus 1/4 y is less than or equal to 3. Because it needs to be less than or equal to 3 hours, our total printing time. So the next one is going to be about binding. So same thing. It takes 3/4 hour to bind one workbook and 1/2 hour to bind one magazine. So our total time needs to be less than or equal to 5 hours. So we have 3/4 x plus 1/2 y is less than or equal to 5. Well, our last two equations are going to be about very simple ones. And those state that we can't have a number of books or magazines that is less than 0. We need to have a positive number of books and magazines, and that makes sense because you can't exactly sell -1 workbooks or -1 magazines. So those ones would just be x is greater than or equal to 0 and y is greater than or equal to 0 because you can sell 0 magazines. Because you don't have to sell magazines. If you can make all your money off just workbooks, then I guess great. I mean, you don't need to sell magazines, and it will still be making cash. So let's graph these now. So this is just going to be like a system. We're just going to graph it like a system, and then we'll do something else. So these will be easy. We already have these. It's just the axes. X is greater than or equals 0. So I picked a graph today that's just showing the first quadrant, because all of our numbers are going to be positive. So all we need to do is just graph these two. So let's put it into a slope-intercept kind of format so let's isolate the y. So 1/4, well, you can't really see that. 1/4 y is less than or equal to -1/2 x plus 3. So now we'll multiply by 4 to isolate the y. So y is less than or equal to -2x plus 12. Right? Because when we multiply everybody by 4, the y becomes isolated. And then 4 divided by 2 is 2, and we have a negative, so -2. And then 3 times 4 is 12. So y is less than or equal to -2x plus 12. And this one is going to be 1/2 y is less than or equal to -3/4 x plus 5. So if you multiply everybody by 2, we'll get y is less than or equal to, and if we multiply 2, if we put 2 over 1, this cancels out, it becomes a 2, so it becomes 1. So 3 over 2, and this is a negative, so negative. So it would be -3 over 2x plus 10, because we multiply the 5 by 10. So let's graph it. And they're all going to be solid lines because everybody is a or equal to. So it's all going to be solid lines. I'm going to graph this one first. So y is less than or equal to -3 over 2x plus 10. So y-intercept's at 10. And then -3 over 2. So 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. And that should be enough. So if we graph our line, should look like that. Let me draw a neater line. Something like that. So that would be our first line, and it's less than or equal to, so we will shade in that region. So that's our first line. Now our second line is y is less than or equal to -2x plus 12. So 12 would be outside the graph, because 10 is my highest. So let's say it's about right over here. That's a bit of an estimate. And it's -2. So even if it was 10, it would just be 10, 1. Let me use a different color. It would be 10, 1 comma 10, because 12 and then -2, so -2 over 1. So we would just have our intercept here anyway, so we don't really need that point, but just to show you. So 2 over 1, 2 over 1, 2 over 1, 2 over 1, -2 over 1. So now we have our line. Okay, and now this is also a less than or equal to, so let's shade. And as you can see, it overlaps right here. In this region, the lines overlap. So our solution region will be right over here. But this still doesn't answer our question, where what is the maximum profit? And this is where we have to do a little bit more than just finding the solution to the system of linear inequalities. So what we do is we find the corner points of the solution region. So the corner points will be the corners of this quadrilateral, because this has 4 sides, so it's a quadrilateral. So we have a point here, we have a point here, we have a point here, and then we have a point here. Now these 4 points are the corner points of the solution region. So first we need to figure out what the points are. So the points are 0, 0, and this one is 6, 0, and this one is 4, 4, and this one is 0, 10. Now what we do is we make another equation. So let me get rid of all this stuff. Oops. I'm sorry. So if you look at the chart, it shows that each workbook makes a profit of $2, and each magazine makes a profit of $2.50. So we can essentially write an equation this time, not an inequality, an equation depicting how we will earn our profits. So what we can do is we make our equation saying profit is equal to 2x plus 2.5y, right? Because we get $2 for each x and $2.50 for each y. So this would basically define our profit, or the amount of money we're going to make. So now what we do is we just start plugging in each of these values, 4 values, into this equation and find out which one is going to yield us the most amount of profit. So let's start plugging in. It's kind of silly to do 0, 0 because we know we're not going to really get anything. Because if we have 0 times 2, which is 0, and 0 times 2.5, which is 0, we're not going to make any money. And that probably wouldn't be the most amount of profit. So let's just keep this. This is 0. Let's say that. So profit is equal to 2 times 6 plus 2.5 times 0, which is equal to 12. So profit for this is 12. Then we plug in 4, 4. Profit is equal to 2 times 4 plus 2.5 times 4, which is equal to 8 plus 10, which is equal to 18. So this one will be 18. And then 0, 10. Profit is equal to 2 times 0 plus 2.5 times 10, which is equal to 0 plus 25, which is going to equal 25. So 0, 10, this point right here, is going to yield us the greatest number, which is 25. So we know that our solution is 0, 10, which means that the maximum profit they can make is essentially $25 a week. And you would get that by printing 0 workbooks and 10 magazines. And that is how you use linear programming with a system of linear inequalities. So thanks for watching. Guru.